Okay, here we go. Lesson 4 for Module 5. We're getting there, 5th grade. We are getting there. You guys are really understanding volume a lot better than I think you would if you were just taught the formula that your parents learned right away. We've been looking at a lot of these little square cubes here, which are called cubic units. They're called cubic units because they're actually cubes, okay? And it's basically how many of these does it take to fill up whatever you're trying to calculate the volume of. So we're working on rectangular prisms, and today we're just going to kind of ease our way into the formula. Some of you may already know it, but we're going to work our way towards it right now. So looking at this rectangular prism, it's asking us what the length of it is. Okay, well, there's really no difference between the words length, width, and height. They're different words because they're different dimensions. You can see that we have this measurement here, which would be 5. I'll call that the length. All right. Then there's this measurement here, which is 2, and I can call that the width. But then there's also this measurement here, which we will call the height, and that is also 2. So we've just said that the length is 5, the width is 2, and the height is 2. So if you think back to yesterday with our layers, if we have slices here, it looks like we have 5 slices of 2 by 2 layers, or layers of 4, which are 2 by 2. And we have 5 of those slices. So what's the volume of this rectangular prism? We have to count the cubes. How would you like to count them? You could count them 5 slices of 4 and get 20. Or probably the easiest way is to look at the bottom layer, which would be 2 rows of 5 or a layer of 10. And there's 2 layers of 10. But either way, you're going to get the volume is 20. Okay? The next one, we'll say this is the length, which is 3. The width would be 2. And the height would be 1, 2, 3, 4. Okay, so to calculate the volume, let's just look at this bottom layer here. That's the way I like to do it. 3 times 2 is 6, so that has a bottom layer of 6, and there are 1, 2, 3, 4 layers, so there's 24 cubic centimeters there. Okay, just for practical purposes, you can think of this as 2 slices. If I cut right down the middle here, if this is a tall cake and I just took my knife, I went right down the middle, that would be 2 slices, wouldn't it? Of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 times 12 is 24. So lots of flexibility here. Okay, in this one, I'll say the length is 4, the width is 2, and the height is 4. Length 4, width 2, height 4. So the volume, again, if I'm cutting it right through the middle here, I would get 2 layers of 16, or looking at the bottom layer, which is 8, I have 4 layers of 8, which is 32. Okay, last one. Length is 4, width is 3, height is 3. 1, 2, 3. 4, 3, 3. So that's a layer of 12 on the bottom. 4 times 3 is 12, and there are 3 layers. So that's 36. You could also slice it this way into 4 slices. Each slice would have 9. So 4 slices of 9 would be 36. Okay, now maybe you're already catching on to a quick way to find the volume when we don't have all these cubes easily visible for us to count. This is asking us to write a multiplication sentence that you could use to calculate the volume for each rectangular prism in problem 1. Include the units in your sentences. So our multiplication sentence for A would be 5 centimeters times 2 centimeters times 2 centimeters. Okay, because when we wrote down, these are in centimeters, right? So let me fill those in real quick. Now, you will see that 5 times 2 is 10, 10 times 2 is 20, and we get 20 cubic centimeters. The next one, B, is 3 centimeters times 2 centimeters times 4 centimeters. And we get 3 times 2 is 6, times 4 is 24 cubic centimeters. The same thing we got up here when we counted. For C, 4 centimeters times 2 centimeters times 4 centimeters equals 32 cubic centimeters. And the last one, 4 centimeters times 3 centimeters times 3 centimeters equals 36 cubic centimeters. Okay, so when we're starting out, I like to write the unit each time. Some of you might not want to do that because you don't like to write, but I liked it because I want you to see there are 3 centimeters there, and that's why our final unit is cubic centimeters, because we have a centimeter for the length, a centimeter for the width, and a centimeter for the height, and that's what gives us our cubic centimeters. All right, so lesson 4, continuing on. So now we're going to do volume without seeing all the cubes, all the individual boxes. See, there's no lines to indicate the boxes. We can draw them in, of course. I'll show you how to do that. But it wants you to calculate the volume of each rectangular prism and include the units in your number sentences. Okay, well, from what we learned in exercise 1, the length is 4 inches, the width is 3 inches, and the height is 4 inches. So that would give us 4 times 3 is 12, 12 times 4 is 48, and our final unit would be cubic inches, okay, because it's 4 inches by 3 inches by 4 inches. All right. Now we're going to do this one, 3 meters by 2 meters by 6 meters. You multiply the length, the width, and the height, and you get 36 cubic meters. Okay, and you indicate cubic units with a 3, a superscript 3 that looks like an exponent, okay? All right. Some of you might not know what an exponent is. That's okay. So Tyron is constructing a box in the shape of a rectangular prism to store his baseball cards. It has a length of 10 centimeters, a width of 7 centimeters, and a height of 8 centimeters. What is the volume of the box? Okay, first thing I'm going to do is teach you how to draw a box. So I want you to draw a rectangle, okay? And that's actually going to be the front of our box, and we know this box is 10 centimeters long, and it's 8 centimeters high, okay? But now we're going to draw the top of the box, and this you do by kind of making a parallelogram off the, it was a little slightly crooked, wasn't it? What you want to do is you want to make your 2 diagonal lines coming off your corners of your rectangle the same length, okay? And that way it'll look more realistic, like square. Okay, that looks better, doesn't it? So this is the depth or the width. Okay, so now I need another, look at this line right here. Diagonal line. I need another diagonal line the same length. Okay, and then you just bring that, connect that straight down, and we've done it. Okay, might be a little bit crooked, but it's not bad, right? So I just drew my box with a rectangle and 2 parallelograms. And this is the width of the box, which we know is 7 centimeters. Okay, so I just drew my box. What is the volume? Okay, well, we're going to multiply 10 centimeters times 7 centimeters times 8 centimeters, and that will give us 560 cubic centimeters. Now, when I was in my head, I said 7 times 8 is 56, times 10 is 560. Instead of going 10 times 7, you'll get the same thing, but I was just showing you how I did it. Okay, so being a perfectionist right now. Okay, that looks good. Last one. Now you're going to have to think on these. There's 2 boxes. Aaron says more information is needed to find the volume of the prisms. Explain why Aaron is mistaken and calculate the volume. So for this first prism, all we're given is the area. Area is 2-dimensional, okay? The area of this rectangle that makes the front of the box. The area is 60. That's all we're given. And then, of course, we're given that the width is 5 centimeters. But you guys know, if you're given that the area of a rectangle is 60 centimeters squared, you can figure out that the length might be 10 and the height might be 6. You can assume it's 10 and 6. Whatever it is, it's going to be 2 numbers that multiply to 60. And so that's enough. Now, we do not have enough information to say for sure that this is 10 and this is 6. But if this is drawn somewhat to scale, it sure looks like that. But there are other things that multiply to 60, like 15 times 4, 2 times 30. But it doesn't matter. So the point is, you're going to take 60, and all you have to do is if you know the area of one face, all you have to do is multiply it by 5, and you will get the volume. And so the volume is going to be, if I do it this way, it's going to be 60 square centimeters times 5 centimeters. And 60 times 5 is 300. But if I multiply centimeters squared times centimeters, I will get centimeters cubed, okay? And same thing here. The area of this is 20 inches squared, 20 square inches. So possible dimensions would be 5 by 4. You could have 2 by 10. But whatever it is, I'm going to take it, and I'm going to take that area, and all I have to do and multiply it by the other dimension, which is the height. And I get 240 cubic inches. So square inches by linear inches will be cubic inches, okay? All right, come to office hours if you need some clarification or if you just want to say hello. I miss you guys. Have a great day.